area of triangles and rectangles. Now we'll remember that area is the amount of space taken up by a two-dimensional shape. And we're measuring that space, as I said before, in squares. That is, how many 1 centimetre by 1 centimetre squares does this space take up? And there's a really important thing to learn about dimensions. Dimensions are at right angles to each other. So when I say how much space does this take up, it's how much does it take up in that dimension and how much does it take up in that dimension that's at right angles to it, and between those, how much space is taken up. Choose dimensions at right angles. So, when we're finding the area, sometimes there's shapes where they give me extra measurements. Like this triangle, they've said this is 2, 3, 4, and this one in here is 1. And you're going, I don't know what I need. Every time we do this, choose the two dimensions that are at right angles to each other for any straight-sided shape that's going to happen. Now, squares and rectangles are really easy. So, if we have a look at, and I wouldn't bother drawing them, a couple of squares and rectangles, we're looking for how many squares they take up. Now, we're not counting the little ones here because we can choose millimeters, centimeters, or kilometers or meters, and so I'm going to choose centimeters. So if I split this into centimetres, I can see that this area is 4 centimetres squared. And I could just split it up. That would be fine. I'm going to split this one up into centimetres, and that's 6 centimetres squared. But there's a shortcut, and I'm sure you know it. Instead of splitting it up very badly into centimetres and counting all the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can see that if you measure this side, that's 3 centimetres, and you measure this side, that's 5 centimetres, then I've got 3 lots of 5 centimetres squared. 3 times 5 says I've got 15 squares. So this is 15 centimetres squared for its area. So squares and rectangles are easy because you just measure the two sides that are at right angles to each other and multiply them together, and that tells you how many squares there are. So, for a square, its two sides are going to be the same. We could call it length, or we could call it S for side. That's not a 5, that's an S. And the area is side times side, or side squared. For rectangles, the sides are the length and the width. Doesn't really matter which one is which. And we need to do area is length times width. So that's the formula for a rectangle for area and the formula for a square for area. Now triangles are a little bit more tricky, but they're actually really easy once you realise that a triangle is just half of a rectangle. So this is the base of this nice little right angled triangle here, and this is the height. If I made a rectangle with that base and that height, so there's the rectangle, you can see that the triangle takes up exactly half of it. Here's this triangle with this base, and now the height has to be at right angles to it. So the height is at right angles there. And if I made a rectangle with that base and that height, then that's half of that side there, those are the same side, and half of that there. This triangle takes up exactly half the amount of space that the rectangle would. So to find the area of a triangle, instead of trying to count all these little bitty part squares, I don't want to do that, we just say, well, let's find the area of a rectangle of that base and height and take half of it. So our triangles, the area is the base times the height divided by 2. Or you can write that as area is half times base times height. And triangles can be a little bit tricky because there's so many different sorts. So I'll draw a couple of diagrams. We could have the base and the height at right angles there. It could be one of these ones where I've got the base and the height is shown at right angles inside it. And every so often they get really tricky and they draw it this way, and that's the base, and they've got these dotted lines out here to say that's the height. But you can tell that these are the ones that we want because they're at right angles to each other, and we always want the dimensions are at right angles. Now this isn't two triangles, one there, one there. This height is the height of this whole big triangle, so it's just base times height divided by 2. So we'll do an example of a square, a rectangle and a triangle, and our steps will be that we choose and write the formula. We substitute the values that we know. We calculate or we solve our answer, and we write the units, and they're going to be units squared because we're counting squares. So, find the area of each shape. This is a square. We choose the square formula. Area equals side squared. The side length is 10, so that's 10 squared, 10 times 10. So the area is 100. Our units in length were meters, and so I'm counting squares that are meter by meter, so I've got 100 meters squared. This is very big. A rectangle. Area is length times width. Doesn't matter which is the length and which is the width, as long as they're the ones that are at right angles, and a rectangle has right angles, so we're good. 3.2 times 6.8, and this will be our last line. Area equals, get our answer, 3.2 times 6.8, 21.76. We were in centimetres, so I'm measuring centimetres squared. Triangles, I've done 3 and I haven't left enough space for the working. That was very silly. So I might just get some extra paper here. Now remember, triangles are area equals half times base times height, or I'll do one of these with the other formula as well. Now, there's only 2 numbers on each of these, but if they were trying to trick us and they said this is 21 millimetres, we wouldn't be fooled, because we want the 2 that are at right angles, because that'll make a rectangle and we can cut it in half. 10 and 15, base and height, it doesn't really matter which is which. That's a half times, times 10 times 15. And you can do that as a fraction if you want, 1 over 2. Or you can do it as 0.5 times 10 times 15, 75 millimetres squared. Don't forget area. This one here, let's use the other formula. It's the same thing, but it's base times height and then divided by 2, which is getting a half. 16 times 6 divided by 2. Keep it all in the same thing. You can't leave out this divided by 2 until the end. And we'll just do that. 16 times 6 divided by 2, 48. And that's in meters squared. This one's one of those tricky ones where the height is outside, but they can see that it's at right angles. So you know you need the base and the height. Area is base times height divided by 2. Write down your values. 3.1 times 4.2 divided by 2, 6.51, and we're in centimeters squared. Now, composite shapes are made up of, composed of, more than one normal shape, and will either have to add or subtract depending on whether they built shapes together or had a shape and took a shape out. So this shaded shape here was a rectangle and they took out this triangle. And the way you're going to deal with composite shapes is you're going to identify the different shapes, find their areas, and then add or subtract. And it's a good idea to label what you're doing. So the rectangle area is length times width. Length and width is 4 times 3. The area is 12 meters squared. Here's a triangle. Area is base times height divided by 2. Now the base is this length here. That's 4 meters. 4 times 1 divided by 2. So the area is 2 meters squared. So you've found the rectangle, you've found the triangle, and they'd cut the triangle out of the rectangle. So then you'd say the whole shape is going to be the area of the rectangle minus area of the triangle, which is going to be, the area is 12 minus 2, so the area is 10 meters squared. So there's lots of different things that we can do with just the area of a rectangle, triangle, and that's about it.